Hello and welcome to a BLT quick take video. In this video, we're going to go over the Vitis export to Vivado flow. This flow allows for you to take your Vitis design and hand it back off to Vivado um, in order to change your programmable logic and finalize your design. This design is specific to being used with the Vivado extensible projects and is specific to the Versal line of AMD FPGAs. What you can do with this particular design flow is you can create your initial design in the Vivado design suite. From here, with your HDL sources and other configuration, we can then create an extensible XSA. This could be done without generating your final bit stream and without doing a potentially time-consuming place and route. That design can then be transferred using this XSA into a Vitis project. From here, the Vitis tool can be used to take that XSA and add more changes to the programmable logic, such as introducing HLS kernels, changes for AI engine development, and make other changes to your project. Just simply using the extensible flow model, once Vitis has done this setup, Vitis can then generate your bit stream, do place and route, and generate your sources to now go and run your design on an FPGA board. However, now with the Vitis export to Vivado flow, it allows for us to, instead of having Vitis generate the final bit stream, export a system-linked VMA file that we can now import back into our Vivado tool. This allows us to do some things in Vivado that would be otherwise difficult to do in Vitis, such as take our final design and do timing analysis or otherwise correct or constrain any issues in our design that may be preventing it from working correctly on hardware, and allows for flexibility in handing off your design between the Vivado and Vitis tools. In this video today, I'm going to go through and show you guys a demonstration of an example project making use of this in Vivado. Here I have an example project in Vivado 2024.1. I can show you how to create this project. If you go to File, Project, Open Example, and we're going to scroll down until we see the Vitis Extensible Embedded Platform. Making use of this project, this will go ahead and set up everything you need in order to create an extensible project that can make use of this flow. But in order to allow for the back to Vivado to work correctly, we are going to need to check this box and indicate that we do want the design to have a block design container. Once we create this project, and I'm going to press cancel now as I have the project already open, we are going to see this example setup that it has been set up for us. We already have a configured SIPs block, a configured NOC, and already set up connections to both our DDR4 memory and our low-powered DDR4 memory available on the VCK190 board we are targeting here. We also have here the board design container. This container is what is actually going to include our design, and when Vitis runs, it will only modify our design within this container. If we click on this, we can see the contents. We can see that as system is currently set up, we have a connection to the AI engine, processor reset, and a clocking wizard. We can also see that on our NOC connections, there are a number of exposed AXI connections that are not connected. When Vitis runs, it will complete these connections for us. Now that this is set up and configured, all I need to do from here in order to build our design is I first need to go to platform setup, and I need to make sure that my master AXI connections, I at least have one connection per domain. Depending on your design, you may want to change this. And as for the clock, we can see that it's saying we have an issue. The clock is not set up. However, this is going to get resolved when Vitis runs, so we can let that be for now. And then we could also set the platform name, but we're going to let that be. I also need to go to my address editor and make sure there are 0 unassigned addresses and make sure that the address table is as I want it to be. From here, all I need to do is make sure the project is saved. And then I'm going to generate the block design. Generating the block design is going to build the associated IP blocks in our block design and set them up so that we can export this to Vitis. I have already run this though, so I don't actually need to run it from that menu right now. And from here, without doing synthesis or elaboration, I can now click on Export Platform. Going to skip generation as that's already set. We're going to do a pre-synthesis output since we have not generated a bit stream and do not want to for this situation. And I'm going to go ahead and do the hardware export. This will only take a minute going through and building the output, creating that XSA for us. Once this XSA is created, we would then pass that into our Vitis setup, whatever set of configurations we have for that. We are getting warnings because the tool thinks that my XSA is out of date, but I'm not going to worry about it right now. I just want to demonstrate the buttons for you guys. I'm going to take the XSA file that has been created, and this file has now been created in my project directory, and I can take that, and I'm going to go through. You can see we now have this external platform wrapper.xsa. I can take this and now add this into my Vitis project, configure Vitis, and do any kind of other setup I wanted. And to jump ahead to there, if I have my Vitis project and it's configured, and I've gone through and done, as shown here, and created this system.vma step using the link and export archive instruction, I can then come back to Vivado and import that VMA file. So I can, here on my computer, I have my VMA file already prepared. So what I'm going to do is I'm going to copy that into my TCL console. And I'm going to type Vitis and I import archive. We're going to set this up, let that run. And what it's going to do is it's going to take the VMA file that Vitis has created for me and add that into our project. And we're going to see how that sets up. This is only going to modify the contents of the block design container. And now we should be able to see all of the aspects within the Vitis design now being propagated back to Vivado. All right, there we are. And now that the design has taken a few minutes and imported, now we can see the updated design. At first, it may not look like much has changed, but what we can do is you can, first of all, if I click on Open Block Design, you can now see that I now have both our external platform BD and I have our BD, external BDC. This first one is going to be just the original version of the block design container that Vivado created. The platform is what we're looking at now. This is the entire system in Vivado. And now we have a VMA um, object as well. And if I actually go back and I show you the platform, I can also see that VMA by clicking to expand this. Now, all of a sudden, there's a whole lot more going on within the board design file. Not only do I have the AI engine, but now the AI engine has been properly configured with all of its connections. The NOC has now been propagated and filled with all of its connections as well. The processor slipping and clock wizard are now all in use. And now we have this sub-region that actually shows all the insides. I can see this view specifically and pull that on its own by going here over to the view partition. Pull this up. We can see the same view. Now we're just looking at the aspect in the board design container that Vitis can edit. And we can even click in here and see now we have some HLS kernels that have been configured and added by Vitis in my Vitis project. We have tie-offs, and this is otherwise configured, allowing us to have a full design in Vitis now imported back to Vivado. This is useful as now I can see complete visibility into my programmable logic, no guessing what the Vitis tool did. And I can go through here, apply timing constraints, manual changes, or whatever I wanted to do to build my final system. From here, what I would do in order to take this design and take the next step is now I can go from here, I can run synthesis, I can run implementation, I can generate a device image, and I can build that final bit stream all from within this tool in this interface. This flow allows for us to hand off between the tools, which may be useful in your case working with these FPGAs. This has been a quick look at the Vitis export to Vivado flow. See you in the next video.